metadata is really all this kind of stuff that surrounds your data that makes the data interpretable or understandable. And it's simple things like sample rate or number of channels if you're doing EFIS, but it's really much more. Metadata is really also all this kind of thing that surrounds the state of the animals. For example, what kind of animal you're recording from, what is the species, what is strain, what is the gender, what is the animal doing in this given time? Have you taught it a task that animal is doing, or has someone taught it a task? What is the surrounding of the animal? All these kind of things need to be with the data to be interpretable. And right now, these kind of things live many places. So, and this is, I'm speaking from my own behalf, but I think this is very common that first it goes in some kind of lab notebook or physical book, then it goes maybe in some kind of spreadsheet, and then something stays embedded with the data, and something lives in your scripts, and when you want to share this with someone else, it's really hard. You have to give a lot of information, and on top of that, it's not really, we don't really have a good standardization for doing this. And so when you're giving someone else the data, or when you're sharing data with someone else or collaborating, we have so many things that are not standardized. So it's a lot of personal language, it's a lot of lab conventions, or certain things you do in your lab that's very specific to that lab, and when you go to the neighboring lab next door, they have a completely different procedure for doing this, maybe very similar things. So that is stuff that's not really documented, and on top of that, there's all these implied experimental conditions that you take for granted, because this is your daily flow, you don't write it down, or in a lab it's implied that this is always what we do. We always do normal life cycle. And then for someone else, it's really important is the preferred life cycle. That's not written down, it's just implied. And then on top of that, the other thing we really want to address is data sharing has a very high entry barrier. So when you want to share your data, it's actually can be a lot of work if you want to do it right. If you want to do it so people can actually reuse your data, or that the data has value, it can be a lot of work actually doing this. It's very time consuming. So we want to make this as easy as possible. So it's really about having a solution where you put people put the experiment in their own skin, describe the experiments as they're doing it as soon as possible. So when you want to share the data with collaborators or publicly, like required by grants nowadays, it's not as much work. And then on top of that, if you put it on a data archive or some kind of data storage repository, the sharing of the data actually has very limited impact. Unless people know your work, it's typically very hard to find the data and know what's really happening here. So they typically have to know your paper, go to the data section, find where you share the data, and then get the data. Right? It's not like there's an easy way to discover what this kind of data is. You're writing a grant, or you're settling and fiddling with your analysis, and you can't make sense of it. We really want to have some kind of resource where you can go and learn from other mistakes, other people's experience, both mistakes and benefits. But we also want this too easy to reuse and make new discoveries from a shared set of knowledge. Okay? So what is BrainSTEM? Simplified is this kind of user-friendly web-based notebook for describing day-to-day experiments, for collaboration and data sharing. So these three levels. It's a website, so all you have to do is create a user account and then you're good to go. You're not storing the raw data, so it's really about describing the data, and then you can link to the raw data wherever it is. It can be on a local hard drive, it can be on a repository or a network location. And right now we focus on experimental neuroscience, specifically behavior and neurophysiology. We don't have so much focus on slides work yet, like tissue handling, but we can discuss this stuff we know are important. And then lastly, it's really this central resource for streamlining data analysis and holding for reuse. So we wanted to cover both experimenters that are describing their experiments, collaborations, but also bridge all the way to data sharing and community aspects. And so why are we building BrainSTEM? The most important reason is nowadays we're capturing so much richness of data across all our labs. And often this kind of thing is not really goes out other places. It stays with the experimenter. And if we can put this as one shared resource where it's well described, it's a massive amount of it's a massive resource we can have. We also think if you're using it, you can accelerate and streamline your discovery. It's very easy to organize your data. If you're an experimenter or a lab, it's very good for organizing data in a lab. It also lowers barriers in collaboration. We thought a lot about how to make sharing easy with collaborators or other people. And then it can really enhance reproducibility and discoverability. This is more like a society impact. And then it aligns, well, that's a little figure, it aligns with the priorities of funding agencies. So nowadays, in our age, and especially the BRAIN initiative, requires that you share the data. This is also true for European funding. So basically, nowadays, if you applying for grants, you have to make a sharing policy, like a document describing how you're going to share it. So already now, you are kind of forced to actually think about this. And some places even require that you're using electronic solutions. And for example, now at NYU, we're working towards getting this approved as an official notebook solution. And this is stuff that could be happening in other places. So NYU is right now saying you have to use benchling, but we're working towards having BrainSTEM an official solution. So it's really about, there's a lot of benefits. And then this is actually maybe a lot of different.
You're working on that, or you have?
No, we are very close to having it.
Okay.
So NYU, I can say more specifically, NYU asking that they can access all their users' data. They ask us to have two-factor authentication. They ask us to have strong passwords. They're also doing penetration testing now to make sure it's secure. And all of these things are actually in place. They need to do the penetration test, but the rest is in a testing phase. So we are hoping this is within weeks. But that depends on how fast the IT department moves.
Are you doing it at the med school or the university?
Med school right now.
And when you say NYU, so who's taking these decisions? Is it like at the department level, or is it at the university level?
I mean, it's the department that's pushing this, but it's the IT department that's approving it.
Okay.
That's my understanding. So they have requirements they want us to fulfill, and as far as I know, we have met all of them now. Now we have to go through testing, and we have to do this penetration test, which is really good for us as well. But I think we actually have met that. So the big thing they want is have access to their users' data. So they want, if someone signs up with a NYU like own address or NYU address, that they can get all the data. And we want to do this on a daily basis. I think this is fine. And it's actually good for this. And they do that with benchling as well. They do copies of all the data. And it's really about, it's not about the researchers, it's really about making sure that they have, if someone making fraud, but they can go back and show that this is what happened. So it's not really about the researchers' interest.
It's more like an insurance policy.
Huh?
It's more like an insurance policy.
It's an insurance policy. Yeah, any questions, just ask me something. The last one is making data fair, and I hope many of you have heard about this acronym now. It's short for findable, accessible, reusable, and interoperable, and it's really a way to capture, ideally, how to share data. But this also really applies for how you describe your own data, your own sake, and for collaboration. So it's even though it's made for like how to share your data in the best way, it's really also about how you describe your experiments in the best way, so when you come back a year later, you actually still can understand it, you collaborate with someone, they can use it, and so forth. And then in even a bigger picture we want to have with this is that we want to create a platform where people can bring their data and collaborate and make new discoveries with all the kind of data we have together as a community. So we want to take advantage of the fact that we have thousands of labs that are collecting a high level of richness of data. That's each of them has a lot of uniqueness to it. That together can become a huge resource. When you put in your data there, it doesn't mean you have to share it. It's really private, and you can choose to share with collaborators or make it public once you have to. So this is what we're hoping for. And it's really inspired by this idea with the Allen Institute has done with the Open School program. So made a program saying that we can provide a resource to give access to level equipment that's not really accessible in most labs. So the idea is that they can do 7 neuropixel helix animal with 5 atomic. There are a lot of stuff that's not really doable in a small lab and build a whole scale of sharing a solution, but we think there's just as much richness and value in our labs. So this is kind of like a complement to this. Yeah, but it requires you guys to actually be part of this as well. So who is it developing this? It's me. It's Elisa Service, who's the director of the data board. We have several people involved. Rodrigo did a lot of the software, and then she's doing now a lot of the documentation. So we have a full documentation website ready. We also done a lot of building a shared set of resources that can be used across, used by users. And then what's really great about this U19 is that we can also have a professional team helping with the technical development. So we have a company, Coin, from which we have a small team we work with on an annual basis. Where we have a front-end developer, we have a senior software developer who's doing a lot of the technical implementation, where we come in a little bit too short when we're researchers, and then there's a project lead. And the big thing here is that it allows us to both build industry standard solution, but also think a lot about the user interface and user experience. So the main features of BrainSTEM, I'm going to show you a demo afterwards, is that we put a lot of thought into making it user-friendly. We want this to be easy to use. You don't have to run any servers, you just create a user and you're good to go. We have this standardized model, which we made in a flexible, extendable way. So what that means is when you're describing a procedure, you have to do it according to some kind of like a template. And this is for it to be interpreted by other people. But we have many types of variations, so you can pick something more suitable to your kind of experiments. Then we made the UI customizable, so we want it to be in a way that you feel like this is fit into your kind of experiment you're making. So you can adjust how you're viewing the data, what kind of filters you want to use for curing and so forth. And then I already mentioned this, we want it to be a collaborative resource where it's easy to collaborate with someone else or have them see your data and so forth. And then one thing that's really strong outside the UI is that it has an API, what's called a REST API. It's a way to interact with the data, both read and write programmably. So it's really optimized for machine readability as well. So you can sit in your programming script, your language, and you can access and read and write to the same source, same solution. And then the model itself, to describe the data, is what we call a relational model. And this is made so we can kind of say, when you're collecting a set of data and you want to describe it, we kind of teasing that apart. So it's not becomes one big Word document. It's really about finding the optimal place to store that information. So for example, if you have a subject, it's not on the subject you write housing solutions or night or day cycle. This is actually related to a housing problem. The weight of the animals are stored one place, procedures are stored another place. But I'll show you after what that means. So what do you get?
Quick question. I'm curious on Python versus MATLAB. How are you seeing that dividing the world today with people you work with?
I think community is split into two. I feel like a lot
Sort
of
of
people.
50-50?
I don't know. What you
We see a lot more Python, but I don't know, that's kind of been shifting in the last couple of years. Especially.
I think, like for example, in EFIS is mostly MATLAB. I would say still because we have a very rich resource of tools that are used by the community. So almost nobody has switched to Python. And the people don't have a lot of tools. So they have to build everything from scratch. And that's their reality. So the people they are now building tools, and this is why you see this in bigger communities. But then if you are in imaging, this is a younger field. They are very much in Python. And it's not idle. There's a strong difference there. But actually, this doesn't relate here. It's built in Python. It's built in what's called Django, which is a Python framework. But the tools you can access with MATLAB or Python. It doesn't matter. And we created very basic tools for MATLAB or Python, so you can use it for whatever language you prefer. Even a third language, Julia, you can use as well. This is the power of the API. You can So what you get if you use this as an experimenter and as a lab, you get a well-described experimental notes, and it's very easy to enter it. It's, I would say, very fast. It's not as fast as your notebook if you don't enter all the stuff that's really important to keep track of. But it is actually, we thought a lot about making this fast when entering data. You get one place to track your experiments. You can, it's a little slow this time. You get simplified collaborations. You get lab notes can be reused in your data analysis, so you can access again with the API, so you can sit, and when you're doing your coding, you can use the same information about your subjects or your cohorts or your set of data sets. You can live one place, let's say a figure. You can keep that in BrainSTEM, what sessions that should go into given figures. You can track that data afterwards in one solution. You can very easily share your data. It's just a one-click button. And it's much easier for people to find the data, so it has a much higher value for the community. And then you get compliant with funding agencies. This is the most boring one, but it's also very quick. So what is the structure and the elements in BrainSTEM? This is actually the side menus. I'm going to prime you a little bit for seeing the website afterwards. So in the top we have projects. Projects are really the way you organize your data. This is where permission lives as well. And under that you have the two primary things, the sessions and subjects. Subjects are made up by the subjects, of course, which is described by things like the genetic line, cohorts, any breeding you're doing, species and strains, and the sex of the animals. There's also free text fields, but then anything you do on your subjects, like what we call procedures, has its own thing. And these are kind of standardized that I mentioned before, so it's virus injections, for example. And here the fields are like how much virus you're injecting, how fast you're doing it, what kind of profile you're using. It's program plantations, the optic fibers, it's training windows, and it's surgical procedures, just to mention some. So these are kind of things, and these can be expanded. Then we also simple things like subject logs, which is like the weight of the animals, how much food or water they're given, their housing, and so forth. Again, please ask questions if you have any. Sessions is really where you would describe your data. A session can also just be training the data. You're actually not doing any recording, so this is the same place before. But a session is made of the state of the animal, the behavior, the data acquisition itself, and any manipulation doing to the subject. So basically, what's the state of the brain when you're doing these recordings? So its surroundings and anything it's not aware of that you're stimulating or injecting or whatever you're doing. Then we also have temporal aspect to this. So you can say, create a session, and then you can say a session consists of many components. Then I talked a lot about standardization. Some of these things are really hard to standardize. So we have things that are personal to your lab or whoever creates this. And these are things like your behavioral paradigm. They are things you describe yourself, because this is hard to standardize. Anything from your memory component task, alternation task, swimming task, whatever you do in subjects. It's also the data storage, so where the data is stored. Is it in a network location? Is it in a cloud? Is it on a local hard drive? So you can track that. And then it's your inventory. So whenever you are in a procedure, for example, say you're using a virus you're injecting, it comes from an inventory of your lab. So you basically, whenever you put things arrive in your lab, you can track, for example, what's the titer of the virus, or how many probes did I buy, or many things. And then it's your setups, which is basically the place where you would do your procedures or you collect your data. So it could be a surgical setup, it could be a ethos rig or imaging setup, it could be a virtual environment. All these things are. So basically, when you're collecting data, you tie that to these kind of resources. And then besides that, we have what's called like shared resources, and these are really stuff that are. It's like a shared list across users. So it's things like your consumables. It could be a fibers, virus, probes. But it's also equipment, so any kind of data acquisition device you're using, injector, stereotax, I don't know, many things, a slicer, vibratron, many things you can keep track of. And then there's taxonomies. Taxonomies are species and strains, for example, but it's also atlases, so brain region atlases. And here we have a lot of resources from other sources, so we have mostly mice and rats atlases, but you can basically use, for example, the Animal Institute's atlas when you say where you're injecting the virus or where you're putting things. This is all in a standardized way. And then dissemination is really journals and publications. So this is more related to, if you have a project, where is that project activity? What's associated with the publication? These kind of shared standards are controlled. So that means if there's a species missing or strain missing, you have to submit it, and we have to actually approve it. And this is because we want to make sure that this is a resource at a very high level of like quality level. So we can't have people submitting the same events for 5 times, for example, where they just spell it slightly different. We want to make sure that things are submitted are really well described and something that really exists. So what that means is that you're submitting a strain. We're working on it across all models, but right now if you're submitting a strain, you can use it right away, but it has to be approved for other people to use it. And the other options right now, you have to submit and then you have to approve. But we are hoping by definitely by this year that the rest also can go directly, so you can use them right away. So the main idea is not to stop you from your workflow. So if there's something missing, you can add it and you can continue entering. But because before it becomes available to everybody, we just like to have a quality control on it. Okay? Yeah, so this is where the standardization can be like a barrier to solve, and I'm going to show you afterwards. I don't think it's such a big barrier. We've really been a lot of effort into making it as small a barrier as possible. So even if you have a lot of genetic lines in your animal, in your lab, you're actually really not creating new species, new strains. You are creating what's called a substrate. So these are not the kind of stuff you need to sort. These are like genetic lines or breedings, or these are doesn't have to go through any approval.
What's the difference between accepting and
Hmm?
what's the difference between accepting?
Yes, so let's say again back to flag 6, if they miss that there's already a flag 6 margin and they submitted like a B6 or something, and we realize, okay, you actually mean flag 6. We can offer to merge their submission with the one we have. So if you're submitting something completely new, it's accepted. If it's something that's actually we already have, we suggest to merge, and then you get 30 days to merge your entry if you want to. You don't have to. And then rejected is the same thing. If we think this is not something that's really meaningful, we can reject, and you get 30 days to change that specific string. So meaning if you submit a subject with a new something that's kind of like we think this shouldn't be that, you get 30 days to change it to something else before it becomes like a generic entry.
Do you expect to have a problem of managing disparate metadata and different sort of taxonomies, because you need to unify them somehow?
Yes, so right now we are a small team who's doing this, but ideally we'd like to have some more people involved in these kind of things. So we have like specific admin teams that can do this, like the resources, species, and strings. But right now we are a small team that does it. Then there's things that which are actually affecting the code itself. So let's say you don't think the number of procedures we have is sufficient for you, then you have to tell us, and you can do that. You can do that through GitHub discussions. So you can say, hey, I'm missing this kind of procedure. Can you add that? And then in a dialogue with you, we can basically add that kind of procedure. We did that with Vincent recently, and we're trying to address this as quickly as possible. Also, if you find any features you're missing or bugs, you can also report that using GitHub. You can basically submit an issue. Yeah. And then for the actual data model, and I know this is intimidating at first, but this is what it looks like. At the top, we have the projects. This is kind of like organization level, that you have subjects, cohorts, collections, and sessions. And then under that is everything that really describes what's happening with the subject, for example, the logs, the procedures. For the session is the data acquisition, manipulations, and behaviors. And what we've done here is we created subtypes that are in a way, so even though you come and say, hey, I'm missing that specific type of data I need to enter, we're not expanding the actual model. We're just creating another type of data acquisition. Okay, so this is also a model that's not going to blow up. It's not going to become a huge monster every time people have input. The idea is that we can actually maintain its size kind of steady. Below we have all these kind of shared things like strains and species, atlases, consumables, hardware devices. So these are the kind of things that you share across users. And it's really also about creating a richness. So when you say I link to a probe, you're not just giving the name, you're actually adding things related to it, because we already entered like how many channels the probe has, the number of shanks, the layout, everything that's actually there. So when you're doing that, you're also adding richness to your data. You're actually making it better. And then for permissions, this is through what's called object level permissions, and it's an inheritance model that starts at, for example, projects. It starts really at projects, and anything below, if you give people access to your data, they can also access those things. So if you, access to the project. So for example, any kind of procedures on a given project, on a given subject that belongs to a project, they can also see this right away. So meaning when you share that with the collaborators, right away they have access to all your nodes. Okay? So this is really strong for collaborations. In terms of how you can add people, they can either be members, contributors, managers, owners. Owners are the one who can change own little project. Managers can add and remove who can have access, and then you have contributors who can actually contribute, create new subjects and procedures and so forth. And then members can just see the data. Okay? So now it's time for the demo. So if you go to brainstem.org, this is the website you're going to see. I already have an account. This is the landing page. So if you want to see what the data actually looks like, we want to go to the dashboard. The dashboard is like a... Oh, I didn't realize I didn't share. The dashboard is kind of your... Okay, I want to go back and show this is the landing page. There's a submission form at the end if you want to contact us outside GitHub. And there's a basic description of the website. And you're going to see a lot of the figures I actually used today. And then once you get to your dashboard, this is what you can see once you create an account. This now gets you a summary of your experiments. So it's, for example, your projects, your subjects, your sessions. The left side, we have the menu I already showed you. We also have what's called a public portal, and this is where you can actually find the data shared by others publicly. So here, the same layout, but just a different color scheme. But now everything is by things people shared for public use. Okay? So here you can actually find things that are not in your collaborations. But if you go back, the dashboard is this kind of overview. At the top, we have my user account, documentation, links to various aspects of the documentation, including this data model I showed you. We also have the link to GitHub issues, discussions, the API tools. Then we have users and groups here. And this is all where you're going to find if people request access to your group. If you request access, this is also controlled here. And then we have this kind of user guide you're going to see the first time you sign up, which is also helping you understand, get an idea about the website, the process. Each of the page has this kind of help log, but let's go to projects. So projects is this organization level, and this is also one of the main views. This is the kind of like a list view, and these are the list of projects I'm part of. And in the top we have the filters that basically allows me to filter the page. So right now it's a search field and create an update, but I can actually change this and pick other things in terms of filters that works for me. The same with the columns underneath. These can be altered. You can select which columns to show. You can reorder them. Each of the entries has this kind of pop-up view, so whenever you hover on a given thing, you can get more information about it. So for example, this project here has 3 subjects, 6 sessions, and so forth. Right away you can see information about the given sessions. You also have this active project list, and as you can see, I have a lot of projects here, and these are actually already filtered, so if I show everything, that's a lot. That also means if I go to subjects, I now have a ton of subjects, and maybe I don't care about that when I'm working on a given project. So this basically allows me to set what projects I want to work on right now. So you can have a list of active projects that basically filters all the pages according to your current focus. Okay, so you're not going to be blown away if you're in a lab that has 2,000 animals across some time. You can actually say, okay, I only care about my current project right now, for example. We also have export functionality. You can recover changes. We have track changes on the entries. We have a help dialog here. Each page has this, so if you're unsure about what fields are really what they are, you can click this small question mark and see. So this is for projects. But actually, let's go and create our first project. So here is assigning who's going to have access. So here picking my lab, and that basically means they're going to have access to this project depending on a membership. So now I create a project. You can see you can also add like description, tags. I can make it public. I'll come back to this later. But this is basically the top level. So let's go and add a subject now. So I go to the subject form, and you can click Add Subject. I'm going to give it a name. These names actually have to be unique across BrainSTEM, project, subject, and sessions, and this is because we wanted to ideally, once you share your data, we don't want to have everything called subject 1, so we have 20 subject 1s. So we want to have some kind of richness also in the names, even though they have unique IDs. It's not the same as if you go and you select a procedure and there's 20 subjects called subject 1 or something. I'm making a string, but that makes it very hard to use. So these actually have to be unique. So you have to come up with some kind of meaningful naming scheme. And then you can see here now I can assign that subject to this project, and that's basically mean anybody who's in that project now also can access it. And these are the kind of standard resources I'm going to show here. So these are the mouse strains, for example. Let's put one of these. So now I created a very simple subject. So you can see what I entered was just the kind of the required field. So you also have a very simple text description where you can put in whatever you want. You can also put in images if you feel like it's necessary. You have the genetic line here of the subject. So this is if you're doing something, like if you're breeding yourself or buying specific animal lines. You have date and birth. You have tags. You have where the animal's coming from, suppliers. But these are really, these are like basic stuff on the subjects. What's really interesting is, of course, once you do something with your subjects, and these are what we call procedures. So if you want to put in a procedure of that subject, so let's say virus injection, this is one of the best visual ones. So now I can pick my viruses I have in the lab. So I have a couple of viruses in my lab. So I can pick that, assign that, saying I'm now injecting that virus into the subject. I can say which table I'm using. So here I have a surgical table from my lab. I can now pick that injector I'm using. So these are like things I created already for the lab. So I already said like I have a number of setups. I have some list of viruses in the lab. And you can also see here I'm using the Allen Institute Atlas, and this is my preferred atlas, and you can actually have your own preferred. And then these are the Allen Institute acronyms. So what you also do here is now you're not only creating like a, what's it called, SSPM4, you're actually creating a link to the Allen Institute Atlas that can potentially be linked to that resource. Yeah? We don't have a direct import function for like CSVs. What we have is right now the API, so you can write a script that can do it functionally. We have been planning this for some time, but we haven't had time to prioritize. We haven't prioritized.
Because we use so many different, like house policy,
yes,
relational database, and other.
I know.
Seems crucial to be able to translate data into
This CSV file is stuff we have been, we can prioritize that. You're not the first saying this, I'm not saying it, but we are, yeah.
That's always very similar to that question before, but like, do we need to do that basically mouse by mouse, or is there a way like, I have in my experiment 50 mice after the show experiment, and each receives a specific ID. Is there any way to work like, or to add this in a way that just mouse by mouse?
One we have what's called a duplication feature. I'll show you in a minute. So it's actually, this is like the best way to do it in the UI. We don't have like a bulk enter model right now, so you cannot say I want to enter 50 models, 50 animals of the same species. That we don't have. What we have again is the API, so you can actually make a script, and it's not a ton of work. You can make a script that does everything for you. I know it's easy for me to say, but this is really the power of API, because this is a limitation of a UI. UI can only do certain things, but with API you can do anything you want. You can build a completely new UI on top of the API. I'd like to say we can prioritize, and potentially we can. They're very similar questions.
I mean, like more broadly, I have like similar questions, but for all these things, like integration with other tools, either at the input stage or output stage, it would be nice to gradually build like a library of recipes. Like, I want to do this, how do I do it?
Yes,
so people can contribute to it, or your team can do it.
Yes, so what we want to create here are templates, so to say. So like if you have a certain procedure you do very frequent, you can create a template. We are prioritizing that next round here, starting this summer. We don't have it now. I'll show you what we have, but we have something that's similar. So let me just finish here. So let's say the virus here. So you can see these fields here actually tailor to virus injections. So you can say how much virus injecting, the rate. Coordinates here are flexible, so you can pick through number of coordinates that you fit your kind of workflow. So I typically use
Bregma-based surface-based coordinates depth. So these now are based on these settings. I'm just going to put in some numbers. So I'm going to save it. So now I have one injection. So let's say I want to do another injection. I just click the button up here saying duplicate. It's going to pre-fill the form. And let's say I only want to change the coordinates down here, so the depth is slightly different. I do this, and I say save, and now I created two entries exactly the same. And then for the duplication, we can do the same thing on a subject level. So let's say you have number of subjects that you've done very similar procedures on. I can go to this subject, I can say duplicate, and I'll give it a new name. And now you can see you can actually also include procedures that are done on the subject. So here I can create a new subject from the other one that has the same procedures. So now I have a subject 2 with the same procedures as before. So this is the fastest we can do now with the UI. So we don't have a batch function as such. But that means that if you start and do the first one, even though you say you do 50, and this is because all of us have a history, and it's a bit harder to handle that history. But if you're coming in and you do similar procedures, it's actually super fast. Once you do the first one might seem tedious, but actually already second you just duplicate and you change those few parameters. And that's the same in a lab. If you're doing similar things in the lab, new person coming in, they don't have to create that from scratch. They take someone else's subject and say, we're duplicating that, and we're just changing the coordinate of that. So it's really, really great for students as well, because they don't have to come in and complete it from scratch and don't know what really matters for the experiment, like what nodes to really track. So you're actually giving them a template as well for how to enter meaningful data about the experiments. Does that make sense? But please ask if you have things that are critical. Also let us know. This is important in a constructive way. What else? So the other thing I want to highlight. So we also made the subject and the session form are the primary forms has autosave. So if you put something in here, a new description of the subject, what you notice is going to autosave my changes, so I don't have to leave the page. Okay, so these things are saved automatically. The same thing if I add a birth date and so forth. This is all automatically saved. So whenever I'm done, I can go back to my list of subjects. But now, let me just show you the subject itself. So when you just want to see what has been done on the subject, this is the detailed view of a single entry. So here you have the subject itself. You have the procedures, so you can see this has a lot of richness if someone else comes in and want to know what you actually did with your subjects. We also have subject logs. So one common one is, for example, weighing logs. Let's say you need to weigh your animals. This is one of the more simpler form, because really weighing is just a single value. So let's say 50. Okay, that's a little high for mouse. 30 grams. I can say it's today. I can add another entry, and then say, I'm going to put that as tomorrow. So let's say I add these two. So now I can actually right away see the progress of the weight of that animal. Okay, so if you're tracking that across days, you get this simple view. And these kind of plots can easily be done. It makes a lot of sense to do that for weighting or food consumptions, but maybe not so much for procedures. We also have cohorts. So let's say you create a cohort of these two subjects we just created. So here I can say I'm using, let's say, both of these in a given cohort. So now I can basically group my subject into similar kind of settings. So this could be animals that have gone through similar kind of experiments or something like this. The other major model are sessions. So these are again when you're typically collecting data. Same kind of logic you apply to the project, and now the sessions, the data acquisition, data is made up of the behavior of the animal, the data acquisition and manipulations, and then the epochs. And the same kind of logic applies here, that you enter whatever you put in. And again here you can say, okay, I'm doing this on a maze, for example, and I'm using this specific data acquisition device to collect the data. Okay, and then the fields here are this is like a long list of steps, but the main thing here is that if you create this initial entry a lot of this you can actually pull it from your data analysis as well. So if you have a script already analyzing your data, you add another function that basically would pull that from your metadata here. So you don't have to enter all of this here. This is a little bit harder to do with procedures, but any kind of thing where you can pull it from the data, this is again the power of the API. And these are suggested fields, of course.
I went through these things, so I recommend for the equipment and setup and so on, starting with resources, right? So before you start entering
yes.
sessions and
yeah,
so create a resource.
Yes, exactly. So this is also what I'm showing you in the tutorial is you need to create these personal resources first. I can show you what we have, for example. So for example, setups here. This is the surgical setup. So for example, this has a picture of the setup, and I can now go to the related equipment and see what exactly is on that setup. And these are the ones I'm selecting. It's also here. I don't know why it's so slow. So these are the main equipment that makes up this setup. Inventories here are where we store the data. So this is the let's go to the one from my lab. It doesn't matter, but basically, when you things come into your lab, this is where you would track. So, for example, if you're putting in, if you are buying a new virus, what you do is you link it to one of these shared lists, and you can create as many intros if you like. You can create one that's called for virus injection. It doesn't have to be like the naming convention here. So, yeah, any of these. Let's say I add this one. So the main thing here is that when you're adding a virus, you're adding them. When did you? So these are the fields going in. So any kind of stock, and these are not required. But you can put in when did you get it? Does it expire? Was it intended for? Ideally, how it should be stored. So this is also really valuable for people in the lab, right? New people, students, other people that doesn't really know the flow, so they can actually find this information. But also specifically for viruses, it's like how many aliquots you made, the titer on the aliquots and so forth. Then behavioral paradigm, this is a little bit more abstract. This is basically what you intend the animal to be doing at a given time. So let's say you train the animal to do some kind of memory task, then that is what you would create. You would create a task that is associated with a type of setup, and these are the one you're picking. So when you're entering sessions as a subject, you're actually picking from these resources here and not directly from the shared resources. Just to show you some of the consumables we have here, there's actually a very long list. Most of these are viruses now. So we import a lot of viruses from AdGene, from the, what's it called, like the brain VTA, I forgot what that is. But various sources, UNC, Vector Core, for example. So we had a lot of their sources. We also have a lot of probe designs, optic fiber design. So these are not a complete list, but actually now we already have 2,600 options. And we are adding a lot of this to make it easier for you to use. So meaning you don't have to submit something, ideally. I mean, you most likely have to, but we're minimizing that effort as much as possible. Then for the approval, let's say you want to submit something, you go to a given form. You would add the name of the subject, the type of species it is, description and so forth, and then once you submit it, it goes into this approval. And then here, basically, we can basically accept or reject whatever is submitted. So yesterday, someone submitted a new fruit fly, for example, and this is stuff we approved, for example. Yeah, we also have the singing mouse you added, so you can see there hasn't been that many submissions yet. But for strings, yeah. Let me see if I forgot something. We have the public API, the public interface. What I also want to highlight is if you have on a given list, you can also see the API, how the data actually would look like. And this is a little boring, but it's really, I think it's really like a strong case. So basically here you can see everything is really stored in the database, or what you would access using the API. And this is like a browsable API, so you can basically browse the whole website like this, and then you can also see it as how it would really look like if you are accessing as a raw code. This is what you would get if you are interacting with the API.
Would you, so I understand
show that there's a procedure which is like a string of BUID there, right? So it's not very, just at that value, it's not very user friendly for the user. They
Yes.
like to, use that and look up wherever else, right? So
Yeah. Let me show you. So the API itself is really intended to be easy to work with other sources. So here's just some we put in. It could have been data joined as well. NeoData Without Border, for example. Dandy, we've been working with both of these to some extent, trying to see if we should create some kind of integration. You can also use in whatever language you have, but we created specifically tools for MATLAB and Python. The API itself is if you care, I can go fast, a little bit quick. But basically, in of these views I showed you can be accessed with the API. It's really just adding the API string in the front. So here's an example for this list of session procedures. But on all of these, you can do filters, you can do sorting, you can include the relationship, which is kind of thing what you said. Instead of seeing a list of UIDs, you actually get a list of sessions, for example, if you're looking at projects, for example. And all of this can be combined, and there's a well documentation, there's a rich documentation of this. These are kind of how it look like if you're using our tools for it. It's very simple. It's you can load a given model depending on first you get a token to get access with your credentials. Then you can load any of the models like this. You can update. It's very simple. It's just save model and then let's say add a description. But on top of this, we also created a Jupyter notebook, so you don't actually have to download any code or anything, and you can use that in Google Colab. So this is what it looks like, and actually the tool itself is available with quick installation, so you can really do everything in Google Colab. Okay, so you actually don't have to run any code. Now this shows you exactly how all of this is done, and this is available on our GitHub website.
And there's a link to that from the UI.
Yes. Yeah, actually, this is really lovely. So this actually brings us to the documentation website. So let me just show you. So if you are on any of these pages, you have this question mark on the top. Also directly here. So let's say you're on subject. You click this one here. So now you get a list of the subjects, procedures, everything here. And then if you want to know more, there's a link to the documentation further. And this is the documentation website. So this is the page for the procedure models, like what each fields are. And then on top of that, we have the API paths as well. You can click here. So these are the fields on when you're interacting with the API. We have documentation of all the models here, but we also have documentation of schemas. So one we made, which I'm really fond of, is the coordinate systems. This was not really standardized or really described anywhere, so we created this one here. And actually, we've been talking with the Alan, and they are using various. I think we are very close to. We haven't aligned fully, but it's almost aligned to their model they're using now for coordinates at the Allen Institute. But this is kind of what you can see here. So what is? I know this is trivial, but what is really APM and DV, like positive, like directionality, angles are well described, which we couldn't find anywhere. What it means when you're rotating your device when you're entering. But you can also see the common coordinate framework by, I think Allen Institute came up with this. We also have here. Then we have this tutorial that we're going to do today basically, but I have it as slides instead. But this actually shows exactly how to move forward. Also, like Vince recommended actually doing your first project, your user account, then projects, and then it's really important to add these kind of things that are specific to a lab, like personal attributes, before you add your subjects and sessions. But there's a very nice tutorial here made by a student in my lab, with small videos even. Yeah, I think that's it for the demo. The framework itself is Django, so we are hosting it on, if you care about that, we're hosting on Heroku, which is using AWS as a host. And the database itself is a Postgres database. And then all the images and files, if you upload images, they're all stored in what's called AWS buckets, which is secure, so nobody but you can see it. And just to highlight some of the stuff we did the last year, as I mentioned, we are now doing this promotion, and your feedback today is really critical. What features you want to have, or what's missing, or also if something breaks, let us know. But just to highlight a few, it's a really annoying speaker. These are kind of things we worked on this year. The global filter I showed you, where you can select your active projects, recover, delete entries, and track changes of everything, so you can see exactly who did what. We now have two-factor authentication and email confirmation on sign-up. We have this expanded approval system. We now have 23 data acquisition types, 19 procedure types, 15 types of manipulation, and so forth. So really putting a lot of effort into making this cover broader in neuroscience. And then we have 2,600 consumables. So making that transition into using standardized things as painless as possible. Yeah. And then in terms of knowledge, I didn't mention Yuri Kusai, he's used to be my PI at NYU. So he was also part of the initial part, and he still is, but he's more experimental focused. We have this company Coin working with us now, and before that we also had a full stack developer. We helped a lot with how to build this relational data model for describing experiments. The funding now is through this U19 grant, and then what we're going to work on now, or working on now, is first of all a bioarchive paper describing a lot of stuff I showed you today. Templates for modules, so making it easier to use to start up and create shared things across a lab. Semantic search is something we're working on, so instead of using all these filters and search functions, you can instead put in a full sentence describing what you have, and it's going to know how to find things in the database. So example is this fine thalamic recording from a sleeping animal with a neurophysiological. It's quite expensive things to do. It's like many places it has to visit, and the idea is that we can create take advantage of ChatGPT to translate it into a meaningful database query that can be run and then present the data in the last. And the idea is to also maintain privacy in your data, so we're not actually sharing the data, we're just asking ChatGPT to make the query string for us. And then we're working on enriching these resources that I mentioned so many times, and then your feedback is really critical as well. So now we can do a little more Q&A, and then after that we'll take a break, and then we have a walkthrough to show you how to get started. If you want to stay for that, you're welcome to leave, but I have to help. It's basically walk through a lot of things I showed you, so creating a user, creating a group for your lab, creating projects, creating all these kind of shared attributes for the lab. So it's the idea is really, if you're a new lab, of course it's going to be uphill, but once that is created, it's actually much more seamless.
So you mentioned this recover function.
Yes.
Can you explain a little bit more, like how much, like, do you say all the edits?
Yeah, let me show you actually. So let's go to this subject, maybe. Yeah, for example, this one we added a description. So if I go to that, this button here shows you the changes we made. So this is all the changes I made that was saved. So this is this day we added the changes to the death date and birth date description. And I'm pretty sure you can recover from any of these. And then besides that, we also have a list of recovered subjects. So let's say you delete a subject by mistake. These are the ones I deleted actually this morning before the presentation. So these are all like demo subjects. But there I can actually go in and recover those as well. And these are based on my permission. So it's really based on permission I had at the state that they were deleted.
What is in that? Like, how do you handle the race conditions? For example, if you delete and somebody else add just that one use, same name, same subject, just different information, and then you try to recover your deleted one, how does that work? Does it work at all? Or you would just throw in the error?
I think it should work fine, yeah.
So, for example, you deleted that subject with that name and somebody else.
Yes,
go and create that.
It's going to tell you it cannot recover it, but actually the other option, viewing, you can actually view it before saving. So you can view it, change the name, and then you can recover it.
I see. So you basically make a new subject then with the exact same information.
Yes. Yeah.
So.
Yeah.
No, please.
You're probably going to answer this, it sounds like, in the walkthrough, but just curious, how does that work with a lab? Is it one lab administrator and then add and subtract people?
Yeah, I didn't show permissions, it's a good thing. So if you have a, let's go to, so again you can do it on project or groups, but let's go to groups, just show it here. So if I have a group here, I'm gonna pick my own, just to not to expose someone else's. So here I have a group, so here you can see the group members, the description, and I can go and edit the information about it, but what you want to do here is click manage, and the manage shows you who has access and what kind of access level they have, and then here you can say you can invite users. So let's say I want to and this is searching across the database, so let's say I want to add this guy to the lab. I can pick how access permissions he should get, if he should be a manager and owner, but if I just do like this, he's going to get an invitation and then he can accept it.
Okay, then they get their own
Yes.
login and password.
Yeah. These have to be users in the database. We cannot invite people outside, but that could be another feature. It's actually only occurring active users.
So that the database is everybody.
Yes, everybody who's a user now. So that's why it was, you saw a type of normal user.
Yeah.
So these are like users in there now. You can also say, so let's say there's a lab, like you sign up and then you want to be part of another lab. Let's say I want to be part of Dennis's lab. So I click here and I can say request access. And then they're getting a request. And it's the managers and owners that get that alert. So not every member, but the ones who actually can do something. And the same for projects. So let's say this project here. You can also manage directly on that project. So you can see I created, so I pick this lab and they become contributor automatically. But let's say I prefer they're just able to see the project. I can say save. So now they can only see, so they can't make changes. But I can add another group in the same way, or another user directly here.
Or if you say, but can you log some I don't know, subject? Let's say you have a complete data set for some experiment. You want to make sure nobody touches it. It's, all the information is there. Can you log that setup? You can see the access, but not edit.
That's basically that would be the group permissions, for example. So if, let's say in this case I gave, so I'm the only one now who can contribute, but anybody else can, they can only see it now. So this is we don't have a log feature as such, but this is kind of logging it only to, I'm only one who can edit those, that we go back here, those subjects, for example, in that session. So it's not logging, but it has similar effect. If these subjects were assigned to another group, another project where other people have access, then of course it would not be logged anymore. Yeah. Any other questions? Yeah.
I might have missed it. But how did you generate groups/labs?
Yeah, I didn't show. So that's good. So once you create an account, you just go to the, I know this is a bit hidden, but up here you have groups, and then you can create a group. And the first thing you want to put in is the name of the group, MIT demo group. So right away it really just have that name. If you want to add information about the lab, you click up here, and now you can say who's the PI of the group. You can say description, and I know it's called a lab, but it's really just as much details about that group. So someone is leading the group, but again, this is extra. The group can just have a name. If you have someone you're collaborating with on your lab, but you don't prefer it's in the lab group, you just create your own group, and the two of you are the members. Groups and users are public, projects are not. So all your projects are really hidden, but all the groups can be seen. But you cannot see what they do. So you could see if you had another group, if like let's say you can have like one for your lab, and this is really great if you have a lot of shared resources. But then you can also have another group just for someone you work with. You can also have it on the project. You can just let the lab see it, but then you have your group member, like the ones you're collaborating with, as a primary direct user of the project. So whatever makes the most sense. Yeah, and then for the same I did say that before, but if you're in a given group, you click Manage, and then here you can add whoever you want to have in the group. And this is again goes across all users. Let's see if there's any. Yeah, so let's say I want to add Vincent to this group. I just send an invitation. Is it okay I click you just to see?
Yeah, I just lost internet.
So basically he's getting an email ideally, and then he can also go directly to this request and invitations, and then he can set, or I can cancel this one here. So now I just cancel the invitation. Any other questions?
So subject and sessions are per project, basically, right? It's a downstream.
But they can belong to multiple projects.
So one session, the same session could belong to multiple projects?
Yes. So if you go in a given session here, so it's basically an inheritance model, but you can have you can add it to many projects. So let's say I want to add it to Julia's project.
Yep.
I just say click, and what's really important here is also when you're doing that, if I'm adding it to no, this is an important point. So if I go to a session and add it to a project, I can only pick subjects within that project. Okay, so it's not like so to add subjects from someone else's project, that project has to be part of that session as well. And this is also to not have it expand. So when I do this, if you go to data acquisition, let's simplify. Let's go to behavior. I can only pick from the subjects that are part of that current project. But if I add another project that has 20 subjects in it, now I can also pick from those. So, yeah, we are minimizing you to have to look at, let's say, 200 subjects, for example. And then for the project filters, so whenever I create a subject, so I had an active filter now, so these are my active projects. But if I go, as you can see, there's like 10 or so. But if I actually go and turn that off, and then I go back to, say, sessions. So now I have all my projects here, for example. So this kind of project filters affects both the drop downs and your list view, everything. Your active project filter up here. So it's really across the whole website. And then once you create, let's say you create a subject, initially you only see the same limit set, but once you actually say, okay, I want to add another project, that option now, that drop down now allows you to pick everything. So like the initial is filtered, so it's more give you a better overview, but after that you have full control, so to say. Any other thoughts? Otherwise we take a 10 minutes break, and then we can I can show you how to set up and create a user and groups, and try to create some of these resources relevant for your experiments. You can get a sense of how easy it is, the hurdles.
Could I see statistics by species, statistics of projects, number of projects, like I'm looking at strengths?
You can. There's kind of stats across users, which is like anonymous. So if you go here, no, actually you can't see. You can see shared things here, like the most popular consumables, hardware devices, strains. So here you can see the most popular strains. For example, we have 241 mice, black 6 mice, 97 rats, and so forth.
Oh, I see.
So
basically, this is a full list of all the species that
yes.
are available.
Yeah.
But some of them are private. Some data is private.
Yes, so these are like stats, simple stats. They don't really expose others' data, but they would say, okay, now there's a singing mouse. If someone used that and it's like the most popular suddenly among the, so then it would be shown.
Does it show which on this list, which data is public and which data is private?
Everything you see here, resources, taxonomies, and destination, these are public lists. These are shared. Everything above is really private. Nobody can see what you're seeing on this. They have the permission to see. but then we have this toggle button in the top where you click public, and then you really see the stuff that people share. And maybe I can show that very quickly. If you want to actually share projects, so let's say this MRT demo that has 2 subjects in it. If I click here and say edit, make it public, I get a warning saying, are you sure you really want to share this? I say okay. And now if I go to this public portal, you can see that the project shows up here. So now everybody, so the idea is really, let's say your paper was accepted and you want to share the data as well. You go there, you click this button, and by doing that, everybody can actually see all the subject going into the paper, all the sessions, all the procedures you did. So it's really a rich level of information to share. And it's really just that one button, so I can show you a little bit, but it's the same, the pages look exactly the same. So for example, here are the subjects we created. You can go and see these procedures. We can go back again. Oh, that was the inventory. Yeah, we can go back to the projects. We can see the cohorts that was used and so forth. So all this is you can make public, and you own the data. We're not going to do it on house. We're not going to do anything. You can make these calls, and you can right now. You can of course also change it back. And it's only the owner of that project. So if you go to the given project, it's only the one who has owner rights that can actually do this. So it's not all the members.
It has links to publications, right?
What?
It has links to publications.
Yes.
Papers.
Yeah, you can do that in projects. So again, let's say this project now we want to, now this has been published, you can actually link it to a publication here. And this is a list that you actually have to add the publication first.
Personal attributes, are they just for you or is everybody?
I would suggest you use them for that. But you can actually, they have to belong to a group, so it makes sense to make them with the lab. It doesn't have to be that group.
Just practically thinking, like, a huge part of planning these experiments is mouse coloring management, and like most of us will have like external resources how to manage them. Is there any thought on how you're going to do this tool?
The thought now is again the API that you can, if it's soft mouse, if it's iMap, I haven't used those, but I heard they have APIs you can pull out information. And then if you have a very small script, you can actually easily do that. Pull it out and put it into BrainSTEM. So again, you can actually create subjects or whatever you want directly with the code. So let's say you have 20 subjects inside soft mouse, that's not what you're using.
Yes.
Then if you can pull that out, you can actually populate the database in BrainSTEM directly. And you can even make a script that do this on a regular basis. But we don't have that script now. But again, this is I like to say we created, but actually there's no limitation for you to do this. We have full access with the API. You can do it for others. You're not limited by us doing a GUI. Of course, it's nice if you did it in a GUI, but I'm saying you can actually make it.
Oh, I don't need to do it.
But you can actually. So you can also make it so, again, I haven't used soft mouse, I actually don't know how to do it for this. You could make it so every day it automatically calls on lines that you did.
This is probably more of an open discussion than the questions. How do you see this integrating or interoperable with Dandy Archive? Right? The way I see this is also an archive, metadata archive, right?
Yes.
Everybody. And so Dandy, NWE is the data format there, and they would recommend storing the data as well, not just the data. So how does this kind of like work together?
Yeah, so we can link to the data anywhere. We cannot handle it. We have to make changes outside, and we don't know. Let's say you move it to another hardware, so you have to run it. But for Dandy, you can link the sessions directly to a like a Dandy object. So let's say we go back to the session. So projects can be linked to archives, and the same for sessions. So if you go to a given session, you can both link it to data storages, and this could be a public storage as well. It wouldn't be here you link to Dandy. Dandy would be in the public repositories here. So here you can pick, you can see it's already pre-selected Dandy, but these are like common sources. You can put in the link to it, and thereby create a link, external link to, let's say, Dandy or Mendeley or Globus or something else.
I'm glad actually that Tim brought this up, because one of the things was Sato was mentioning to talk to you was about exactly
Yes.
how to integrate this with Dandy to make it actually even easier for anybody who wants to like store in WP. And
Yes.
you have this like go back point, just like do this, and you know we can actually talk to people at the end of WP.
Yeah. We actually have been talking with Benedicta about this.
Okay, talk about
We
it.
even have an application about creating integration tool.
Okay.
But that didn't get funded this round.
Okay, because they have this sort of like NeuroCon, NeuroGuide, all this sort of thing. Yeah, exactly.
So the idea is that we kind of made a code for what it would cost to make this kind of like a NeuroCon, but for BrainSTEM. So the idea is that you have your local data, you have your stuff in BrainSTEM, and then you can combine the two to populate the files,
Okay.
and then put it into something. Dandy has, in my opinion, limited metadata around all those kind of things, and we put a lot of input
Exactly,
into.
and that's the idea, like, you know, because Dandy's metadata is mostly about, like, you know, what each person decides to put in there, right? But this is very comprehensive, because, you know, through the like, experiment, someone can, you know, write down all the metadata like this. Very fruitful, right?
So I think it's really complementary. What we can also do with the mission is, of course, take what they have and actually describe that in BrainSTEM, so it's easy to find the same data into the Candy files.
Yeah, and one of the cool things actually is happening now, recently is also they had sort of like a hackathon last week, which is basically the idea that, okay, can we, there's even another layer that's being built using LLMs, all sort of things to use them as a search to deep dive inside the metadata, all the information that exists in a picture data set. Having a system like this would be very useful.
Yeah. Yeah, very much. So this goes a little bit along this semantic search direction we would like to go. It's a lab manager in Yuri Busagi's lab who's working on this now. Okay. The semantic search. He has a software engineer background. So the idea is to start with semantic search, but it could be more and more integration with both the language models and.
So you know Jeremy
Macklin, yeah.
So Jeremy, he's building sort of LLM-based.
Yeah, exactly. We got the inspiration from him.
Okay, great.
So he built this into his NeuroSift.
Yeah,
exactly.
Now go to NeuroSift, you can chat with LLM.
It's his approach we're using.
Yeah.
So ours is a little bit tricky because he's doing it on public data.
Yeah.
The same data on Dandy is all public, but we want to maintain privacy here, but giving you the search field function. So we don't want to send the data out to some chatbot, so it's a risk of exposing it. But if you make a query, that query is going to go out. So potentially, if there was a leak, it's only your question, your search function that will be search string that will be exposed, and nothing else.
There's a lot of data on Dandy that is not public because it's still embargoed.
Yeah, that is true, but I don't know how they handle that actually.
Yeah.
For the NeuroSift, because that exposes. That's.
Yeah, if you go to if you go to NeuroSift, I think it's then public, right? Yeah, I don't know actually. Like we should ask Jeremy because
we actually
have
asked
a
him.
layer of like the public versus non-public repository. Then the action should be different.
Yeah. But it's exactly his approach he used for NeuroSift that we are integrating here. Should we do a break and then?
Yeah, I think it's good.
Yeah.